Okay, so let's open the syllabus, and this is the second class in Java development. Okay, and I have the module open over here. So in this module, going to the OOPS concepts, that is something which you will learn in the entire module. There is not a single concept which I can tell you in a single day, but over the time you will get to know what are the OOPS concepts. Okay, how inheritance, and these are the concepts which we will know like in next 2 or 3 classes. But now where we stand, we have seen how to compile the code. Okay, how to write the code first using an editor, then how to compile that, then how the dot class file is generated, and how to run that dot class file. So that thing we have already seen, right? Now the next class is about, okay, the next class is about a little deeper into Java programming, in which we are going to learn about the variables, then how these variables are created, how these are initialized, okay, how you can assign some values at runtime, how you can modify the values of the variables. So these are the things which we will learn in this class, okay, and how to create classes, that you have already seen, just an example of addition test. But in this class we will be dealing with different types of classes, okay, how to create different types of classes, then how to create their objects. Okay, we have just created the classes, we have never created any objects. So today we'll learn about creating objects. Okay, then this is the main important thing of Java, how Java really works, right? What are the components of Java? So one is JVM, one is JRE, then what is a JDK, then why these things, like how these things they work together, and something about the platform independence of Java. So platform independence is something, once you write some code in Java, then you generate the bytecode using Java C, Java compiler. That bytecode you can take anywhere, any system, and you can run, and you will get the same output for the same set of inputs. That is what Java platform independence says. So let's first see how this JVM, JRE, and JDK, these three terms are different. Okay, and we have a web page open. Okay, this is, okay, in Java we have three components. One is JRE. Okay, so what actually JRE is? So if we see from the top down, we can say we have a JDK. Okay, you can see the screen, right? This is the main like the biggest component, the super class, which is containing everything, and we call that a JDK, right? We call that a JDK. Inside JDK we have a JRE, and within JRE you can say you have the JVM. So let's go first into this JVM, what this JVM is. So you remember, to run a Java file we must first convert it into a bytecode which is understandable by Java virtual machine, right? So now this JVM is something which will understand your bytecode, right, and it will help you run the Java code on any platform. So JVM is like it's an application which is developed by Java that can understand the Java's bytecodes. Okay, and in JRE you have this JVM. Okay, the JRE is something, okay, JRE, we call JRE as Java runtime environment. So JVM needs to run your code, JVM needs to execute your code, but it needs an environment in which it can execute your code. Okay, and JRE is something which will give you that environment. We have lots of jar files, we have lots of libraries available in Java. One of them is called rt.jar, which is called runtime library, runtime, Java runtime. Okay, so now this Java runtime and other library files which are dealing with the system, with the console, with the output, input, and everything in that system, with the memory structure, with the processor, CPU. So these are the libraries which are available. Okay, and JRE is doing what? It is just providing a runtime environment to the JVM so that JVM can execute your code. So what you will need to give to JVM? You need to give to JVM a Java .class file. Okay, that has the bytecode. JVM can run that, but with the help of JRE, with the runtime environment that JRE is providing. So There are two types of installation of Java. One is called standard Java installation, which is containing only the runtime environment JRE. Okay. Another is called JDK, Java Development Kit. So JRE is something which can only help you and help JVM execute the Java code, execute the bytecodes generated out of Java source files, execute some Java application. For that reason, you will need JVM or you will need JRE, okay, which can just execute the code. But you need to compile the code first. If you are a developer, you need to compile the code first. You need to write the code, then you need to compile that, then you can create an application out of that, right? To help you code, to help you like use other libraries that Java has already built, like Java has already provided you. So these are the libraries which you are going to get with JDK. That is called Java Development Kit. So that kit is going to help you write Java code, compile them so that you can generate some bytecode which can be given to JRE for running. So JDK will help you with Java compilation. We call that Java C, Java compiler. Okay. So JDK will only help you in compilation. Okay, it will tell you if some compilation error is there. And once you execute that code, once you call Java, Java then space addition test or Java then space your class file name, then that is going to do what? That is going to execute that code. For that reason, it is going to initialize your Java runtime environment. It is going to give that class to JVM. JVM will execute that. So these are the things which will happen. But as a developer, you need to download the JDK, Java Development Kit, which will have the development libraries, Java compiler, Java executor, and it will have the JRE in itself, which is going to have the runtime.jar file and the JVM built in itself. Okay. Right. So this is how like basically Java looks. Now comes platform independence. Right. This is the JDK that you are going to install into your system. Right. And within that JDK you have a JRE. So this JRE is something which is going to play a great role to make your Java code platform independent, right? Once you have written some Java code, it's in .java format, you have called Java C, which is part of the JDK. So JDK has compiled your code and it has generated a .class file. Now the .class file, it doesn't know on which system it is going to be run, right? It just knows some commands which this JVM can understand, because at the end JVM is going to use that .class file to execute, right? This JVM can be run on any system, on a Linux system, on a Windows system, on a Mac system, on a mobile, or any hardware which is capable of running Java. So this JVM is ready to understand that hardware. So you will get a different JVM for Linux, you will get a different JVM for Windows. Okay, that JVM knows how to display in Linux and that JVM knows how to display in Windows, right? So JVM is going to use your system library, Windows library or Linux library to display something onto the screen. Okay, and JVM can understand the Java bytecode. So there are two interfaces for JVM. One is to understand the Java bytecode that you have written, that like Java bytecode that is generated from what code you have written using Java compiler. That is going to be same for all the JVMs. You will get different JVMs for Linux and Windows. They will get the same bytecodes, but to execute them on the system, on the machine, on the Linux or Windows, they'll have different ways to handle it. On Linux, it will use some different commands, Linux commands to display that on screen. On Windows, it will use a different command. So that is something which is restricted to JVM only. Okay, JVM will understand the system level commands. Okay, so JVM has made it open for you to write any code in Java. Just give him the bytecode. JVM will know how to run that on a system. Okay, so JVM can be downloaded for Linux and the same JVM version for Windows can be downloaded. There will be two different files. they know how to deal with Windows and how to deal with Linux. You just need to give them the bytecode, and JVM knows how to call Windows commands and how to call Linux commands. It will make you open, like it will give you an interface where you can just put code Java like bytecodes, but at the end it'll give that command to the system in a different way, and that makes your platform independence. You'll get different JVMs for Windows and Linux for different platforms, but the same bytecode is like something which they are consuming. Okay.
The JVM is system specific. The
Yeah,
JVM.
perfect. JVM is system specific, understanding the system level code.
So it comes with a JRE pack or the install it differently?
Sorry, it comes with.
JRE installation file or the install it separately?
Yeah, JRE is just jar files. JVM is something executable file for Windows and executable file for your Linux. So that is different, but JRE is same and JDK is same for all the systems. JVM is going to be different. And if you are downloading JRE, then you will have only the JRE library and the JVM machine
Mm-hmm.
and the JVM JVM executor. But if you are downloading JDK, you will have the development tools like Java,
It's 10 o'clock.
Java C, and all these things. And also with that, you will have the JRE with JVM. Okay.
Yeah.
So you now you got like how it becomes platform independent, right?
Right.
Okay. So, any doubt in these two things like JVM, JRE, and JDK? Just first remember the full form of these words, and you will get to know the meaning of them, because Java development kit, it is going to help you, it is going to give you a kit to develop. For that reason, it is called JDK. Java runtime environment and Java virtual machine. JVM is something which is going to run the Java code. So and JRE is going to provide the runtime environment. So from the like abbreviations, you can get to know what it is. Okay.
So what do you mean by environment? It's the environment.
Sorry, what is needed?
So then by runtime environment you mean whatever the jar files is needed for execution of the
Right.
bytecode,
What are
right?
the things needed as a runtime environment that you are asking?
Uh,
Because that is something which Java knows how to handle your file. Because last time we created a file which is called addition test, right? That class is called addition
mm-hmm.
test class file. So JVM just knows how to execute, how to call the system level commands, how to call the system level commands so that our output can be displayed on the screen, on the console, right? But JRE knows how to extract those information out of our Java, like how to execute, like how to extract this code, the statements, those bytecodes from the class file. Okay, so JRE will give you a runtime jar. JRE will give you lot many like different things which will help the JVM to execute that code. It is something which is deep into the Java framework. Okay, basically it gives the access to the system and all this. It initializes the memory structure and lot many things.
Mm-hmm.
Okay, should we proceed then?
Yeah.
Okay.